Assalamualaikum, my name is Nur Eliana Alisa binti Ahmad, S64257. Introduction. Firstly, optical fiber are thin, flexible and standard used for data communication and measuring sunlight incidence angle. Secondly, a setup consists of a light source, optical fiber and sensor. Next, the fiber capture is coming sunlight, transit it to the sensor and analyze the intensity and direction. Last but not least, this measurement is used in fields like solar energy, agriculture and architectural design, where understanding the angle at which sunlight hits a building or solar panel significantly impact its efficiency.
Assalamualaikum and good morning. My name is Daniel Kipi alias. My metric number is S2039. Today I will propose the measure the angle of incidence of sunlight using optical fiber. Firstly, measure the angle of incidence of the sun by utilizing the principle of total internal reflection. So, optical fiber are used to measure the angle of incidence of the sun by utilizing the principle of total internal reflection. When the light enter an optical fiber at angle greater than the critical angle, it reflects off the inner surface of the fiber instead of passing through it. The angle of incidence can be calculated by measuring the angle at which the light is reflect. So secondly, a bundle of optical fiber is placed in a fixed position and oriented toward the sun. So to measure the angle of incidence of the sun, a bundle of optical fiber is placed in a fixed position and oriented towards the sun. As the sun moves across the sky, the angle of incidence change and the amount of light reflected by the fiber also change. By analyzing the amount of reflected light, the angle of incidence can be calculated and used to determine the position of the sun. The purpose of this presentation is to introduce a low-cost system for measuring sunlight incidence angle using optical fiber. So this system has the potential to revolutionize the way we measure sunlight incidence angle and could have wide-ranging application in field such as solar energy system, agriculture and architecture. By the end of the presentation, we will have a clear understanding of why measuring sunlight incidence angle is important, the limitation of traditional method and how the low cost system using optical fiber works. You will also learn about the advantage of the system and how it can be used in a real world application. So next, I will explain about physical variable. So one of the key physical variable that affect sunlight incidence angle in the Earth's rotation. As the Earth rotates on its axis, the angle at which sunlight hit a particular location changes throughout of the day. This means that measuring sunlight incidence angle requires taking into account not only the location of the measurement but also the time of the day and reason. So another important physical variable is the position of the sun in the sky. So the angle at which sunlight hits a surface will vary depending on whether the sun is directly overhead or closer to the horizon. This means that measuring sunlight incidence angle requires taking into account not only the location and time of the day, but also the position of the sun. So the most common method for measuring sunlight incidence angle is by using a digital inclinometer. This device measuring the angle between the sun's and horizontal planes, providing a quick and easy way to determine the incident angle. However, it has some limitation. For example, it requires direct line of sight to the sun and cannot be used in cloudy or overcast condition. Additionally, it may not provide accurate measurement when there are obstructions such as trees or building. So, optical fiber is a powerful tool for measuring sunlight incident angle by using a special sensor at the end of a fiber optic cable. It is possible to detect the angle at which sunlight strikes the surface of the cable. This information can then be used to calculate the incident angle of the sunlight. One of the key advantage of using optical fiber for this purpose is low cost. Unlike traditional method of measuring sunlight incident angle, which require expensive equipment and specialized training, optical fiber system can be easily set up and operate by anyone with basic knowledge of the technology.
Measurement system. Firstly, the author developed a numeric model to predict the optical performance of antioxidant with stationary compound electrolytic concentrated ACPC to increase electrical generation by 2%. This added to a 57% increase in yield control compared to a fixed PV board, showcasing the low cost and productivity improvement. They also proposed a show to understand the electrical characteristics of a PV cluster under different shading conditions and introduction considering invert voltage impact. Next, device like the Solar L864 LXS SOL medium concentrate obstacle light and sun eye 210 are used for sun-oriented location estimation and solar energy generation. In specific zone, this device measures available solar energy by day, month and year interval, determining shading design and determining the direction and position of the sun. However, this simple device may be costly, potentially increase the overall cost of a PV facility. Then the section present CAD design. Part of a 3D printed system. Available in STEP format and 3D printing technology like FDM. Each piece performs a specific function and can be modified to include additional equipment. The system used 33 optical fiber to analyze sun-based frequency using a hemispherical process.
A low-cost system uses a microcontroller and data storage component like an SD card to process optical fiber signal, allowing display or storage on an LCD monitor or sent to a distant server for immediately monitoring and analysis. Next, a low-cost system uses a servo motor or actuator to measure sunlight incidences angle using optical fiber. A microcontroller compares angle data to set point, ensuring accurate measurement and maintenance. The processed signal can be displayed or saved in a low-cost system for immediate monitoring and analysis. Last, wireless transmission and control component can be added to low-cost optical fiber system for monitoring sunlight incident angles. This component enable real-time data transfer, remote management, and easy control. A servo motor or actuator can provide feedback, ensuring accurate measurement and maintenance in varying lighting conditions. This process signal can be displayed or saved in a low-cost system for immediate monitoring and analysis.
Now, block diagram. The input is light, forward to detector, to low noise preamplifier, to main amplifier, and to demodulator, and the output is electrical. Okay, now I will explain a part number of material. We have we choose 8 number of materials. One is sensor piece. The number of material is only 1. Union piece 24. Acrylic base 2. Fiber matrix 1. Fiber holder 24. Base piece 8. Bar end 8. Aluminium tube 4.
Syakiran Surati binti Ahmadi S62018. Now we will move to the application of the system. The initial validation process primarily focus on the assessing the optical properties of the arcelic dome to ensure that it is not have the determinant impact on the irradiance readings. Previous research has utilized spectrometer to conduct similar validation on the polymetal metacrylate substance, which is commonly used for the dome. Spectral measurements were taken both inside and outside of the dome to determine its transmittance characteristic. The transmitter curve display revealed that the dome is having approximately 95% transmittance in the 400 until 780 nanometer wavelength range. However, there is a decrease in the transmittance observed in the 380 until 400 nanometer range. The arcelic dome can be observed from the top view, covering the assembly of the part, while the showcase the internal structure of the device, specifically highlighting the matrix responsible for collecting the optical fiber. The optical fiber are wrapped in the PVC for protection and to prevent the interference from nearby fiber. The component present in the arches align the tip of the optical fiber which capture light. The opposite end of the fiber are connected to the yellow matrix located at the base of the device.
Conclusion. In the nutshell, the low-cost system for INCI disentangle measurement entail laying an optical fiber on a surface and measuring the angle of the fiber with respect to the surface. Second, this system can be made to be accurate, portable and simple to use, delivering vital information for many different sectors and research fields. Third, this system can help people to make it easy for them to do daily activity or work, such as farming and agriculture can benefit from this measurement. Overall, this system is a special tool that offers to make it, and the effect its cost must be expensive to involve this system. Thank you. That's all from our group.